Good morning to all of you. I hope you have gone through the first video of polar coordinates. That day we left somewhere, and that was relation of unit vectors. The main points that we covered on that day is in polar coordinates, there are two very important quantities, and they are known as r cap and theta cap. R cap is a unit vector in the direction of increasing r, and theta cap is a unit vector in the direction of increasing theta, and they are perpendicular to each other. That is the first thing we have introduced in our last lecture. The second thing that we have very important, and that is this r cap and theta cap, they are changing with time. At different positions, r cap and theta cap are in different directions, not unlike I cap and j cap. So this is the most important thing that we have learned. Now today, what we are going to learn mainly in polar coordinates, how to calculate the velocity and acceleration. These are the two important quantities that we are going to see, that how we can derive an understanding of it. That is quite important. So let us see. So these are the relation. The first we have to study is relation between the unit vectors. That is from the last class. I hope you have done it. Then dr cap by dt, d theta by cap by dt, velocity and acceleration. So these are the four things that we are going to learn today. So let us start with the first one, that is relation between unit vectors. Relation between unit vectors. That means r cap, j cap, how they are relating with r cap, theta cap. They are relating with I cap and j cap. Okay. So let us redraw the same diagram now. So this is your x and y coordinate with the origin O, and let me extend this line from here, say a point P, and let me use red pen here, red chalk. So let us do this. This is your, suppose say, r cap. Alright. Theta cap also, let me draw perpendicular to it with a red chalk, that is your theta cap. Okay. Then parallel to x-axis, I have the I cap vector. So let us draw I cap here, I cap, and parallel to y-axis, I have the j vector. So j cap vector. So we have this j cap vector. Good. I hope it is very clearly visible to you. Now this angle is theta. So if this angle is theta, then if I extend this line, this is also theta. This is also theta. This angle is pi by 2 minus theta. This angle is again theta. This angle is your pi by 2 minus theta. Alright? Good. Now, basically we have to find out the relations between r cap and theta cap. Sorry, r cap and theta cap with I cap and j cap. So let us write. R cap is equal to r cap. Now, here what I will do, I will make a rectangle like this, and the I cap and j cap, both the components along the r cap direction. That is what the r cap will be, because all are unit vectors. So here I write I cap cos theta plus j cap cos pi by 2 minus theta is sin theta. Alright. I cap cos theta plus j cap cos pi by 2 minus theta is sin theta. Theta cap is equal to let us reverse this I, that is minus I cap over here. So minus I cap cos pi by 2 minus theta is sin theta plus j cos theta, j cap cos theta. Good. These are the two most important relations. I cap and j cap also we will write down in terms of r cap and theta cap. So I cap is, let us extend this line over here. What is this? This is minus theta cap. And this angle is pi by 2 minus theta. So I cap is, I have to write in terms of r cap and theta cap. So I cap, what is I cap? R cap cos theta. R cap cos theta plus minus theta cap. So minus theta cap, I can write minus theta cap cos pi by 2 minus theta is sin theta. Then j cap is this one, j cap. So j cap is r cap cos pi by 2 minus theta is sin theta plus theta cap cos theta. So these are the relations between r cap, theta cap with I cap and j cap, and I cap and j cap with r cap and theta cap. I hope this is clear to you. Now out of these four relations, mostly we need these two at present. So I box it out, these two one, alright. These two are the most important one which we need. We do not have a space here, but we can write this in terms of matrix also. R cap, theta cap, then cos theta, sin theta, cos theta, and I cap, j cap, that way matrix form also. It's okay. We don't need that much. But these are the mostly these two relations are very, very important. Alright. Now let us calculate the velocity vector, because that is what we are interested to learn. Velocity. Alright. Now, if I want to calculate the velocity, first I will write the position vector. So r vector is r cap, and velocity is equal to dr vector by dt, which is ddt of r cap. This is equal to dr dt r cap plus r dr cap by dt. Okay. Now this is equal to r dot r cap plus r. Now here is a problem. dr cap by dt. This is a vector, unit vector, which is changing, isn't it? This is changing, and so we don't know how to do it. So here lies the problem. And here lies the problem. So how can we do it? What we find that, what here we infer is that when we calculate velocity and acceleration, we are concerned or we work with few relations or few expressions or few quantities. R theta anyway is there. R dot theta dot R double dot theta double dot. Alright? And there are two more quantities, that is your dr cap by dt and d theta cap by dt. Alright. Obviously, these quantities I can easily write, r dot, theta dot, and easily calculate. But this is changing. R cap is changing and theta cap is changing with time. So, I cannot calculate it unless I calculate, first of all, I have to calculate these two quantities, only then I can calculate the velocity vector. So, I am not prepared or I am not equipped with my tools or with my expressions. So, first of all, I have to calculate these two quantities. Otherwise, I cannot calculate velocity. So, let us rub it out. Alright. So that is why I have written here, our next step is to calculate dr cap by dt. So now we will calculate dr cap by dt and d theta cap by dt. These are the two quantities that we need to calculate. They are very, very important. Okay? So let us see how we can do it. So the first one, that is your dr cap by dt, how we can calculate that? Any idea? Because r cap is changing with time. And if r cap is changing with time, how to calculate dr cap by dt? That is my challenge. Any answer? Okay, so let us see what we will do. R cap is changing with time. What we can do, we can express R cap in terms of I cap and J cap. At the same time, theta cap in terms of I cap and J cap. Now the derivative of I cap and J cap is known. They are 0. They are fixed vectors. And then I can proceed. Alright. So let us write R in terms of R cap in terms of I cap and J cap, which are fixed. So let us see what is R cap. So now our expressions, I cap cos theta plus J cap sin theta. So let us write R cap is equal to I cap cos theta plus J cap sin theta. Let us write dr cap by dt. Dr cap by I cap is fixed vector. So I will write I cap. Then d dt of cos theta is d d theta of cos theta into d theta by dt. You know that. So d d theta of cos theta is minus sin theta and d theta by dt. So like d theta by dt. Plus again J cap is constant. d dt of sin theta, I can write d d theta of sin theta into d theta by dt. So it is cos theta into d theta by d. Okay. Now what I write, this is equal to minus I cap sine theta, d theta by dt is theta dot, plus j cap cos theta, d theta by dt is theta dot. And I take theta dot common, that is theta dot minus I cap sine theta plus j cap cos theta. And this we know very well. What is this? Minus I cap sine theta plus j cap cos theta. That is your theta cap. So this is theta dot theta cap. So dr cap by dt is theta dot theta cap. Alright. Now let us calculate the other one, d theta cap by dt. So this is the first one. This is the second one. Now we calculate for the theta one. So second one is theta cap. Let us write theta cap. Theta cap again we will write in terms of I cap and j cap. So this is minus I cap sine theta, minus I cap sine theta plus j cap cos theta. I differentiate, so d theta cap by dt is equal to minus I cap sine theta differentiation cos theta. Then I will write theta dot directly plus j cap cos theta again is minus sine theta theta dot. Alright. And here we can write theta dot I can take common, minus sine also I can take common. Then I can write theta dot and minus sine at both places I have taken common. I can write I cap cos theta plus j cap sine theta. Now what is this? I cap cos theta plus j cap sine theta. I cap cos theta plus j cap sine theta is r cap. So minus theta dot r cap. Okay. So these two relations are very, very important. So what I do, I write it in a box because I will need it often. So I make a box over here. Let me write over here. That is your dr cap by dt. Dr cap by dt is equal to theta dot theta cap, and d theta cap by dt is equal to minus theta dot r cap. So let me make it red because these two relations are very, very important. So these are the two relations. dr cap by dt is theta dot theta cap. d theta cap by dt is minus theta dot r cap. Now it looks very confusing to you, isn't it? But it is not at all confusing. The thing is, when I am differentiating r cap, I am getting theta cap. When I am differentiating theta cap, I am getting r cap. Now, basically, this particular expressions we have been doing unconsciously throughout in our circular motion. So let us understand it a little further in circular motion. Physical interpretation, alright? Physical interpretation. What actually does it mean actually? The physical interpretation of that. So let us take dr cap by dt first. Dr cap by dt. What we do, let me draw a circular, whatever we have studied, circular motion. So let us take a circle over here. Alright. Now, let us take that in this circle, there is a particle which is moving in the circle. Let us take these points as A, B, and C. A particle is moving in a circle and it has some radius. Whatever the radius is R, and this is O. Now, we have been doing this all throughout. You see, this is your r cap vector here, alright? R cap vector. Here, your r cap vector. Here, your r cap vector. Okay? Now, as this particle is going from point A to point B, this r cap vector is changing. Now, when this r cap vector is changing, I have to find out the derivative. How to find out the derivative? The way is this minus this divided by delta t. Limit delta t tends to 0. That is how we find out the derivative. So, let us write this as Rf and this as Ri. And let us think that this time period is very small. So what I do, Rf minus Ri. So what I will do, let us draw a negative vector here, Rf minus Ri. So just parallel to this, I draw a vector exactly parallel to this here in the opposite direction of the same length. Alright, same length. So the resultant vector that we get by using your parallelogram law of addition is the resultant vector is something like this. It should be basically, the length should be the same, then you get a tangential vector. So this is the resultant vector. So as you see, the derivative of the radial vector or the r cap is in the theta cap direction. So this is your theta cap basically. And this we have been doing all throughout, where in the circular motion, when a particle is moving like this, the position vector of the particle, the position vector, this is your position vector, the position vector keeps on changing. And when you differentiate that position vector, you get velocity, and velocity is basically along the tangential velocity. So basically when you differentiate the radial vector, which is basically changing, you get the velocity vector which is basically tangential. So this we have been doing in our circular motion. So where basically when you go from position vector r to calculate the velocity vector v. When you do it, that is your position vector to calculation of velocity, basically unconsciously we are not so conscious about r vector at that time, but basically that is what we are doing. Now let us do for, alright, so now after dr cap by dt, we will see d theta cap by dt. So let us see d theta cap by dt. So again I will make the same similar circle. Okay, with origin O. Now let us see that I choose three different points, point A, point B and point C. So let us say point A, point B and point C. Alright. Now let me draw the velocity vector, but I will not draw the velocity vector because we are doing d theta cap. So basically it is velocity, a body is moving in a circle. So I will draw the theta cap vector. So here is the theta cap vector. So this is your theta cap. At the point B, this is your theta cap. At point C, this is your theta cap. Alright? So theta cap is changing with positions or with time. Now, as we have done here, let me write this as theta f and this as theta I. Alright? So the derivative of theta is theta f minus theta I divided by delta t. Limit delta t tends to 0. So again I will do the same thing. So let me draw a parallel line, exactly parallel and same magnitude as theta I, but not in the negative direction, that is this way. Exactly parallel. Okay. Now if I add these two, so if I add these two, basically I will get a vector which is the resultant vector. This is the resultant vector. Now as you see, this is in the r cap direction. R cap direction. So d theta cap by dt, d theta cap by dt is minus theta dot r cap. And that is what we see here, that d theta cap by dt, that is the change when the velocity vector is changing. So basically here, when the velocity vector is changing, then we get the acceleration. And acceleration, as you see, is pointed towards the center, and that is what we call centripetal acceleration. So this is the physical interpretation of this or geometrical interpretation of d theta cap by dt. So the derivative of r cap is in the direction of theta cap. Derivative of theta cap with respect to time is in the direction of r cap. Both are theta dot. That means with what angle it is rotating, that is what it matters. So, but here it is minus sign, as you see it is towards the center. Good. Alright. So now we are equipped to calculate the or to derive the expression for velocity. So let us write velocity. Velocity. Alright. Good. So velocity v, I have to calculate. What is velocity v? Is d dt of r, the position vector. And what is my position vector? So it is d dt. R is, the position vector is r cap, r cap. R cap. So let us calculate that. So d dt of r cap is r dr by dt r cap plus r dr cap by dt. Okay. Here we can write this as, this is r dot r cap plus r dr cap by dt, dr cap by theta dot theta cap, theta dot theta cap. This is my velocity vector. Alright. Velocity vector r dot r cap plus r theta dot theta cap. And you know very well, because a body moving in a circle where r dot is 0, it is the tangential velocity, r theta dot, r omega, which you have read. Now, this particular term, basically, this we can, what we write, the magnitude, these two magnitude, we can write as, this we can write V sub r, and this we can write V theta. Alright? So, the magnitude of V I can write V as, okay, let me write over here, V, magnitude of V, I can write as VR square plus V theta square to the power of half or square. So that is the magnitude of V. Okay. Now let me show you little bit through a diagram. How does it look like? This is your xy axis. Suppose a body is moving like this, something like this. Now here, as you see, the body is moving in a curve, now not in a circle. This is a general case I have taken. Now here, this is your O. Now, at any point, suppose say P, you extend this line. This is your r cap vector, as you know, and perpendicular to this is your theta cap vector. Alright? This is your V of r, and this is your V of theta. And when you add them up using your vector addition, then this is the resultant you get. Alright? Which is your V vector. So this is your VR, r cap, V theta, theta cap, and this is your resultant V vector. Okay, so geometrically, at least you can see that if you are asked to calculate the vector V, then basically you have to draw this diagram. But if you are asked to calculate the magnitude V, then this is the formula. So let me just okay. All right. Now let us come to the acceleration. Acceleration. So acceleration vector A is dv by dt. We all know that. And now we will write the expression of V in the polar coordinates. that is r dot r cap plus r theta dot theta cap. Okay? Now, the d dt of this. So, just let me d dt of v, that is r dot r cap plus r theta dot theta cap. Okay? Now here I will write one step which is quite trivial, but it is very important. So I want you to pay your focus your attention on that. What I will write, so d dt of r dot r cap, that is one term, plus d dt of r theta dot theta cap. Alright? Now, it is very trivial, but these two terms, what does it mean? It means, because when we go and we will see the answers or the expressions at the end, it will be very clear that why I have written like this and why this step is important. It is important because our velocity vector consists of two major terms or two terms. The one is the radial term and other is the tangential term. Now this radial term consists of two things, that is two, r dot and r cap. So the acceleration arising from this portion of this particular term on the radial part, r dot can change, r cap can change, both. Here as we see, the tangential part consists of three, r, theta dot and theta cap. So the acceleration along this particular, that is your tangential part basically of the velocity, the acceleration can come because of the change in r, change in theta dot and change in theta cap direction. That is actually a most important to understand the expression for acceleration. Now let us write this one by one. So all is algebra, but we have to be a little careful so that we don't make mistakes. d dt of r dot r cap. So it is d dt of dr dot dt, dr dot dt r cap plus r dot dr cap by dt. That is your first bracket closed. Plus second one, d dt of r theta dot theta cap. So I can write, no hurry, d dt of r theta dot theta cap, okay, plus r theta dot d theta cap by dt. Okay, this I can write r double dot, still I will maintain this bracket so that I don't make mistake, r cap plus r dot dr cap by dt, dr cap by dt is theta dot theta cap, theta dot theta cap. First bracket closed, plus now d dt of r theta dot. So let me start the second bracket. So I will, just for I don't make mistake, let me take another more bracket. So it is dr by dt theta dot plus r d theta dot by dt and curly bracket closed, theta cap plus r theta dot d theta cap by dt. D theta cap by dt is minus theta dot r cap. Minus theta dot r cap. Then other bracket is also closed. Okay. Now I will open up the bracket. So this is r double dot r cap plus r dot theta cap plus dr by dt into theta dot. So dr by dt is r dot. Alright. So r dot theta cap plus r d theta dot by dt is theta double dot and theta cap plus, or I can say minus r theta dot d theta dot is minus theta dot r cap. Minus theta dot r cap. So it is minus r theta dot square r cap. R theta dot square r cap. Okay. I hope it is clear this step till this step. Now what I will write, let me write r cap common, r double dot, so r cap is here and here, so minus r theta dot square plus theta cap you see r dot theta dot, so this is one, r dot theta dot second expression, r theta double dot third expression. So I will write 2 r dot theta dot plus r theta double dot, that's all. This is my expression for acceleration in polar coordinates. Now exactly the way we have done for the velocity, this particular part we can say this is your A of r, and this particular part we can say A of theta. So we can write magnitude of A is AR square plus A theta square to the power of half or square root, whatever. This is also an important expression to calculate the acceleration. Is this clear to you? Okay. Now we have to understand 1, 2, 3, 4 terms. Okay? Now here this diagram will help us, and also this expression again will help us. So here I write down all the terms also. R double dot is your radial acceleration. R theta dot square is your centripetal acceleration. R theta double dot is your tangential acceleration. Alright, in the d theta direction. So all these basically in the theta cap direction. In theta cap direction. This is theta cap direction. These two terms are basically unknown to us before. R dot theta dot, that is change in radial direction of VR. Alright? That is the velocity in the radial direction is changing. Change in the radial direction of VR, because of the change in the direction we are getting that. And R dot theta dot is change in R which changes v theta, and because of that we are getting this acceleration. So these are the 5 terms. Okay, thank you.